Hello, welcome to the NorthStar Controller Segment Routed LSP Provisioning Learning Byte. I'm Gordon Mosley with the Education Services Department at Juniper Networks. Let's get started. After successfully completing this learning byte, you should be able to successfully provision a segment routed LSP using the NorthStar Controller. The NorthStar Controller Administrative Interface allows you to provision a segment routed LSP. In the Network Info pane Tunnel tab, the Add button will present you with a Provision LSP window, where you will be able to specify the provisioning method, in this case PSEP, specify your segment routed LSP name, the ingress and egress nodes represented in this diagram or in this screen as Node A and Node Z. So Node A is the ingress node Z is the ingress node of this segment routed LSP. The unique thing about provisioning a segment routed LSP is specifying the provisioning type. The normal provisioning type is RSVP. So we depend on the RSVP protocol to distribute labels for the label switched paths. But segment routing, we use the IGP. In this case, we're going to use the ISIS protocol to distribute the adjacency SIDs and node SIDs required to establish segment routed LSPs. So we change our provisioning type from RSVP with the drop-down menu to SR, segment routed. Now all of the other options are the same. I'm allowed to specify the routing path. I can specify how I would like this segment routed LSP to be routed. I can specify a schedule. So the standard NorthStar Controller LSP options are available to me. The only thing that's unique here is changing how this label switched path will be provisioned. So in this case, we're going to use segment routing. Once the segment routed label switched path has been provisioned to the ingress node, there are some operational mode commands that I can execute on that node to determine the label switched path status. In operational mode, there's a show spring traffic engineering LSP detail command. The output of that command will list all of the segment routed LSPs by name. I can identify the outgoing interface, and the interesting information to me is I can look hop by hop by hop how the traffic for this segment routed LSP will be forwarded across my segment routing domain, right? I can view the labels, which is very important for me because remember, the labels are generated based on the IGP adjacency SIDs. The adjacency SIDs or the MPLS labels that will be stacked onto the packet by the ingress router, in this case VMX1, when the traffic enters this segment routed LSP. So I can see hop by hop how this traffic is going to be forwarded. Another command that's very useful to me on the ingress node is a show route command, and that will also show me where traffic forwarded to a particular LSP endpoint, the egress node, how that traffic would be forwarded, what labels would be pushed onto that packet before it's forwarded across the segment routing domain. I'm going to demonstrate the configuration using the NorthStar Controller interface of a segment routed LSP. Now, the network that you will see once I enter the NorthStar administrative interface is this one, right? So you need to be familiar to help you better understand this concept. I need you to understand where we are, right? Whose kitchen we're in. So I'm going to create a segment routed LSP. The ingress node will be the VMX1 node, the node you see here on the left side of this diagram. I will provision a segment routed LSP to the VMX2 node on the right-hand side of the diagram. Now I will use a couple of options in the provision LSP window inside of the NorthStar Controller GUI. I'm going to route this on the most circuitous route possible. I want the LSP to ingress on the VMX1 node. I will forward traffic to the P1 node, then to the P2 node, diagonally to the P3 node, then to P4, and we will egress. The egress label switching router will be the VMX2 node. So what I want you to pay attention to, right, we're going to tell the NorthStar Controller to provision this LSP for us, we're going to specify the path that this LSP should take. And remember, this is a segment routed LSP, so we will use the adjacency SIDs for the labels. So what I want you to focus on is let's look at our path again. The labels that will actually be stacked on traffic that ingresses the VMX1 node and egresses the VMX2 node will be the adjacency SID between the P1 to P2 node, which is 1032. Then it will go from the P2 node diagonally to the P3 node. So there will be another label, 1082. This is the adjacency SID from P2 to P3. Then the adjacency SID from P3 to P4, 1092. Then the adjacency SID from P4 to the egress node VMX2, 1111. So the interesting adjacency SIDs for us for this segment routed label switch path is 1032, 1082, 1092, 1111. And we'll see this after we have the LSP provisioned. Okay? I'm going to connect now to the NorthStar Controller interface and provision a segment routed label switched path. This is the NorthStar Controller administrative interface, and in the topology map, this represents the network diagram we saw on the previous screen. Here is my VMX1 node. I'm going to provision a segment routed LSP toward the VMX2 node. And so in the network info pane, I'm going to click Add. This brings up the provision LSP window. I'm going to specify a provisioning method of PSEP. This is the protocol that's used to communicate label switch path configuration and status and monitoring information between the NorthStar controller and the MPLS ingress nodes, right? And so I'm going to give it a name, just whatever you would like, VMX1 to VMX2-SR, whatever sounds good to you. Now what I'm going to specify here with the drop-down menu, the node A is the ingress node, so I'm going to specify VMX1. I want this segment routed LSP to terminate on the VMX2 node, right? The only thing that's really unique here is I don't want to use RSVP as the provisioning method. I don't need RSVP to distribute the labels, right? I'm depending on my IGP, which in this example is ISIS, to distribute the adjacency SIDs, which will be instantiated in an MPLS forwarding plane as labels. So I'm going to specify segment routing. Now, my other options, as I mentioned previously, the other options are still available to me, like a forwarding path. So let's do that, right? We said we want to ingress VMX1, egress VMX2. Let's specify a preferred forwarding path. And this allows me to specify, loose hops, strict hops through the segment routing domain. And so once it ingresses VMX1, I can hit the drop-down arrow here just by the hops. As I mouse over, you can see how the traffic would be forwarded. So I want to go from VMX1 to the P1 node. I can click the plus symbol to add another hop in the path. Let's go down to P2. So let me mouse over. There's the next hop in the path. I'd like the traffic to then be forwarded to the P3 node. Slide this out of your way here so we can kind of see the path as it's being built. The next hop in the path I'd like to add, let's go down to the P4 node, right? And then I want this LSP, to then terminate. Oops, I went too far. So I'm specifying just a manual path, just like I would with any standard RSVP signal LSP. I have the same link color options, right? We still do traffic engineering. I can specify, how this traffic is routed between these specified hops. I can schedule this LSP, right? So the same options that I would have. Our big difference here is specifying how this label switch path will be provisioned. I do not require RSVP because this is a segment routed LSP, right? I don't need RSVP to distribute the labels, right? So I'm just going to hit submit. If I think positive, my label switch path is now, the NorthStar controller will compute the forwarding path, will signal using the path computation element protocol to the VMX1 node. Here is how I would like this label switch path to be forwarded. And in this case, the best sign is the operational status of this label switch path is up, right? I can see the forwarding path that's been signaled, so all is well here. Now more information is available. Let me scroll to the right. All right, and I can see the configured route, right? We said hop by hop by hop by hop, how we would like this label switch path to be forwarded. And I can also see, I've displayed on the topology map the adjacency SIDs, and I can see the recorded route and verify, okay, the path that I configured when I provisioned this label switch path is the actual path this label switch path is using. Now, another way to verify that, right? So we talked about in the explanation how you could actually, there's some commands that you can execute on the actual node itself. So I'm going to connect to the VMX1 node. We're going to execute some operational mode commands so you can see the effects on the node itself of the LSP that was provisioned by the NorthStar controller. I've connected to the VMX1 node, and I'm going to run a show spring traffic engineering LSP Detail command. Now, this command will list all of the segment routed label switch paths that initiate on this particular ingress node, the VMX1 node. In this case, I can see the name of the segment routed LSP that was provisioned from the NorthStar controller. So I see VMX1 VMX2 SR. I can see the egress node, 172.20.20.2. This is the VMX2 node, the egress node of this label switch path, my outgoing interface. And then what's beneficial to me is I can see hop by hop, okay, hey, this particular path that I provisioned in the NorthStar controller is the forwarding path that's actually being used by the ingress node. So I can verify that this was provisioned correctly. I can actually see the label values that would be used hop by hop by hop to forward this traffic from ingress to egress on my network. Another beneficial command is a show route command. Now I'm going to run a show route command, and I'm going to focus on the egress node, right? This is a label switch path, from VMX1 to VMX2. Now I'm going to staple a detail switch on the end of this command to give me a little bit more information. Now we're running ISIS as the IGP inside of this routing domain. So I've always had in my inet.0 table a route to 172.20.20.2. But now, since the NorthStar controller has provisioned this segment routed LSP, there's a new route placed in the inet.3 table, right, that points to 172.20.20.2 that has a better preference than the route in inet.0. Segment routed LSPs have a preference of 8, right? So if traffic ingresses VMX1 destined to VMX2, it will be forwarded using this segment routed traffic engineered LSP, right? Now I'm going to focus on the route we have in inet.3. I can see this is a spring traffic engineered, label switch path. I can see the next hop. I can see my outbound interface. But the main thing I want to focus on here, look at this label operation. I want to push 111, 192, 182, and 132. These are the labels that map to the adjacency SIDs for the forwarding path that we defined when we provisioned this LSP using the NorthStar controller interface, right? So 111, 192, or 1092, 1082, 1030. These are the labels that will be popped as this traffic is forwarded through the segment routing domain, right? So the show spring traffic engineering LSP detail and the show route command can allow you to verify that the NorthStar provisioned segment routed label switch path was provisioned correctly through your segment routing domain. In this learning byte, we learned how to provision a segment routed LSP using the NorthStar controller. Thank you very much.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.